Good morning, sir. Rajesh, sir. Are you able to hear me, sir?
Yes, sir. Very good morning, sir.
Yes, sir. I'm Dr. Nathan, host. Good morning, sir.
Pleasure.
I'm Dr. Nathan, host of this session, sir.
Oh, okay, okay, sir.
Okay.
It's pleasure meeting you, sir.
Your voice is audible.
Uh,
Let us wait for another
sure, sir. Sure, sir.
participant. And
Sure, sir.
join.
We'll wait for it, sir. Sure, sir.
Okay.
Okay, sir. How about my voice clarity? Like it's all fine, right, sir?
Voice is audible, sir.
Okay, sir. Okay, perfect.
Clear. We also clear, sir.
Okay, sir. Perfect, sir.
Yes, sir.
Sure.
Good morning to one and all present here. I welcome all of you for this 5 days FDP session 13. By Dr. Rajesh Ranganathan, professor from Coimbatore Institute of Technology, Coimbatore, to deliver the expert talk on customized split insole for the diabetic patients. Let me introduce Dr. Rajesh Ranganathan for the audience. Dr. Rajesh Ranganathan is currently working as a professor at Coimbatore Institute of Technology, Coimbatore, India. Working at CIT, he lectures module in supply chain management, supply chain information systems, rapid prototyping, and rapid manufacturing. He heads the Advanced Integrated Manufacturing and AMP Management Research Group at CIT and Director for Center of Excellence in Manufacturing Sciences. Only center in India funded by Ministry of Human Resource and Development, Government of India. Dr. Rajesh holds various projects accounting close to 11.62 crores. Dr. Rajesh, for his outstanding work on diabetic food management, received an Young Scientist Award from the Department of Science and Technology, Government of India. He is integrated with the Loughborough University, Imperial College London, and University of Sheffield in UK, Stanford, Massachusetts Institute of Technology, University of California, Santa Barbara in USA. He is also guiding researchers in different disciplines of manufacturing and management. He has about 18 journal publications and authored a book, Rapid Manufacturing as an Enabling Technology in Supply Chain Improvements. VDM Verlag, Dr. Muller EK Publisher, Germany. He is also an editorial board member for about 5 international journal publications. Working in the area of supply chain, Dr. Rajesh holds work experience as a business consultant, knowledge transfer partnership, associate working for oil and AMP gas industry in Aberdeen, Scotland, UK. Dr. Rajesh was also associated with the University of Aberdeen, UK as a knowledge transfer partnership associate, where he was bridging the gap between industry and academics. Prior to his career, In oil and gas, Dr. Rajesh worked with the National Health Service UK and with the leading healthcare industry in Europe in the area of strategic planning, technological forecasting, inventory reduction, product customization, and manufacturing lead time reduction. Dr. Rajesh obtained his doctoral degree in additive manufacturing from Loughborough University, England, UK. During his PhD, he was with the world's leading research group, Rapid Manufacturing Research Group. I welcome you, sir, for this session. I hand over the mic to you, sir.
Uh, Thank you, sir. Very good morning, one and all. First of all, I'd like to thank Professor Nathan for a kind introduction, and I'd like to thank Professor Rajendran for inviting me for this knowledge sharing event. And having said that, I would like to welcome everyone. And in this presentation, I'll go ahead with the presentation to start with, and then we have a question and answer session a bit later. And Nathan sir, is my screen clear?
It's loading, sir.
Okay, sir. Okay.
Yes, sir. Visible,
Right.
but you need to make it a slideshow.
Yes, sir. I have made it a slideshow.
Okay.
Yeah. Okay. So, like, to start with, when Professor Rajendran contacted me for this guest lecture, he straight away asked me to speak about this particular topic. It's like it is one of our very renowned work. So he was very specific to stick to this. I'd like to thank Professor Rajendran once again for pulling this topic. So in this particular topic, to start with, I'd be discussing on what is our research focus and where we are at the moment, and then I would we'd see what sort of technology that we are using, what sort of additive manufacturing technique that we are using for this particular research, and then we'll speak about a bit about diabetology. The reason is the entire research is focused towards diabetology. So a bit about maybe some portions which you already know, we'll be touching on that. And then I'll be discussing what is the role of a mechanical engineer into this and how we have integrated additive manufacturing onto this. So I was quietly observing a couple of other speakers. So you could, I could hear from all the speakers saying, or most of the speakers saying that additive manufacturing is one technology which is completely suitable for custom manufacturing. So we take up that particular line, and that is where you'd see much of the things rolling on. Like. So is my screen moving on? Are you finding me in the third slide?
Actually, sir, no, sir, no, sir.
Oh,
Actually,
okay.
the slideshow mode is not enabled, I think.
Oh,
Please check
okay.
again.
Yes, I got it enabled in slideshow, but I don't know, for some reason it is not.
Sir, you try to reshare, sir, again.
Yeah, sure.
Yes, sir. Now in slideshow mode. Rajesh, sir, kindly unmute.
Am I audible, sir?
Yes, sir.
Okay, right. Um, like as I was saying, in terms of our research group, we are roughly about 18 members who are working together as a team, and we do have some international candidates who move up and down and who work with us in terms of various healthcare-based research. We combine two major technologies. One is on additive manufacturing, and the other one is from the supply chain perspective. And combining these two, we can explore on many areas, but our focus is limited within healthcare. Uh, and again, in supply chain, we can see many areas, but we limit ourselves with how we can produce low cost products, how we can reduce inventory, how we can reduce lead time in terms of manufacture, and how we can be agile and responsive when combined with additive manufacturing. From additive manufacturing, we look in the perspectives like how we can improve customization, how we can produce complex profiles, how we can go for high accurate parts, and where we can go for parts wherein we can reduce the lead time. So these are the major areas that we focus. And for this particular case study, we or roughly about 80% of our work revolves around this particular polyjet printing technology. We have one of these machines back at CAT, and it's a Polyjet technology wherein you have obviously 8 print heads. And the one reason that we went for this particular technology is we can use multi-materials. And here I have shared with you one example wherein if you are looking for a product which has or which involves a transparent part, we can go for this option. If we need an ABS, we can still stick to it. And finally, if we are planning to go for rubber-like parts, still we can go for rubber-like parts. If you are looking for any other options, or when we purchased, we had limitations in that, but now we have many technologies which came up. But when we purchased in 2013, we were looking for the combination of these three to be blended together in one single technology. So that is where we went for this particular Polyjet printer for sticking to our products. So here we can print two materials at one single time, and it also provides us with yet another option of digital materials. What it means as digital material over here is, let's say that I want to combine material A and material B, and combining these together, I want to print a third material. In our case, say for example, if you want to print a rubber-like material with a show hardness of 100D, which is a very hard one, and if I want to print a material, print a part which is bit flexible, so I can stick to show hardness of 50D, so which is the medium range. So in this application, I can go for a variation in 20D, 40, 50, 60, 70, 90, and 100. So this particular machine gave us an option on that. So that is why we thought we'll stick around to this. And you'll see how we are using this when we speak about the case study. For people who haven't came across this one, I thought I'll give a slight overview on this particular one.
260 Conics uses inkjet printing technology that can jet two materials at the same time. This allows you to produce models containing a whole range of material properties to more accurately represent your final product. Each layer of resin is just 16 microns thick. It can even mix two materials to create a whole selection of properties, such as this material, which is tough enough to simulate ABS-like engineering plastics in applications such as this, or even this, that can do this. With Object's 3D printing technology, you can take your design idea and rapidly transform it into a functioning prototype. And you can do this with all the subtle details of your intended product built in, including the different material properties of assembled goods, such as this part. Multi-material technology is that you can build up to 14 different material properties, textures, and shades into a single part in a single print job. Object has an incredible range of over 60 materials, from rubber to transparent to engineering plastics, with the ability to mix and match various combinations of
So end of the day, with this particular technology, we can print parts like if you are looking for transparent parts, which was possible in SLS, in stereolithography, we can do it over here. Anything that we can print in SLS, it's possible. And even at times some colorful products. And very importantly, you can have a combination of ABS and a rubber-like material, which goes or which can be printed together in one single go. Usually the alternative approach would be like you print a rubber-like part separate and then you put an additive compound and you stick it together. But here we can print in one single go, we can print both these two combinations. So this was one thing that we were looking at. So that is why we went for this particular technology. So coming to the healthcare domain, we all know that healthcare domain is quite a very vast one, and there are many areas that could be explored. And specifically, our focus is on prosthesis. Within prosthesis, we have two options. One is the internal prosthesis, and the other one is the external prosthesis. When it comes to internal prosthesis, anything that goes inside the body that falls under the category of internal prosthesis. Some products like this, mostly metal parts are the ones which are considered for internal prosthesis. But as we work most on terms of rubber and plastics. We don't do anything at all in internal prosthesis. We work completely on the external prosthesis side. So when we speak of external prosthesis, anything that goes above the skin, so that falls under the category of external prosthesis. So our focus is completely on the external prosthesis side. So going to this particular case study, this particular project we did at Coimbatore, and our contributors for this research or hospitals in and around Coimbatore. We collaborated with nearly 3 different hospitals for this particular project, and we used the sample population from Coimbatore, and most of our data have been collected during the sugar testing camps or the diabetic camps which were conducted in and around Coimbatore. So those were the data sources for us. So why is that we concentrated in terms of diabetes? So we all know that diabetes is the 4th leading cause of death, and by 2030 it is predicted that roughly around 439 million people would be affected across globe, and Tamil Nadu ranks highest within India in terms of diabetic population, with 13% in the urban and 3.5% on the rural areas. One interesting fact is, I would say one sad fact is, like every 20 seconds, a leg is lost across the globe because of diabetes. This was one of the key things that caught our eye, and you'll see how our research got aligned with this. And majority of these leg amputation is because of the ulcers, and ulcers are caused by the human loading, and ulcers was a major reason for these amputation. And International Diabetes Federation estimated that 70 million people in India would be diabetic by 2025, and 2030 India would be the world's leader in diabetes, which is a sad fact to know. And this is a disease which is growing across globe, not only in India, across globe it is spreading at a very drastic rate. So in terms of our research, as I mentioned to you, like we used data population in and around Coimbatore, and for us we had about 2,570 respondents who were involved in this project, and we got the data from these population, and of which male population is about 1885 and female population is about 685 female population. And we did happen to test the data validity, and reliability and validity of the data was found to be fine. Sticking to that, like we try to collect some information from the Diabetic Survey. We realized that there are people who visit the doctor once in 2 years, 3 years who are diabetic, and hardly people visit the diabetologist or the diabetes specialist. They still stick to the general practice now in terms of checking their diabetes level, because the complications are getting in a different zones, and which people are not much aware about it. And from our survey, we got a couple of data which relieved the facts that more than 50% of the respondents were aged above 56 years of age. Of this population, only 64% or only 36% meet a diabetologist, whereas the rest of the population meet a GP. And that is where the complications started, or we could see that is where it is starting, because after some time I'll be discussing some graphs on this, so you will know where it is coming up. And of this population, 52% of the population have or already faced or are having foot-related complication. And when we see about diabetes, there are 5 major complications which occur. One is high blood pressure, foot problems, high blood pressure and foot problems, which come hand to hand, and neuropathy and foot problems, which again come hand to hand, and heart disease and foot problems, they also come hand to hand. So, in general, of the entire set of disease that we saw that 26% of the population, one way or other, face foot problems. So that is why we realized we'll stick to this foot problems and we'll see what we can do in terms of this. So when we were focusing on foot problems, and we did happen to ask a question like how many diabetic patients are aware of the situation of foot problems. Of this, only 42% of the population were aware of it, and of the 42, when we asked their idea on custom insoles, only 43% were aware of custom insoles, and rest of them, they weren't aware of a fact that diabetic patients need to go for custom insoles, or for that matter, even a diabetic shoe exists or diabetic insole exists. So that was one of the sad facts. So what is that diabetic foot is? Here is a short video which gives an outline of what a diabetic foot is. Uh, right. So we did happen to see a video which demonstrates what is a diabetic foot from the medical perspective. They clearly highlighted, or it could be seen from the video that they showed there was some sort of wound at the bottom face of the foot. So that they called it as a diabetic foot in simple terms to start with. So then we just dig a bit in deep how it happens. So wherein we look from the engineering perspective as well, and that's how we opened up many more lines onto it. Let us consider that there is a diabetic patient, and doctors say that he has an issue of diabetic neuropathy, wherein he or she loses his or her senses in the foot, in the bottom face of the foot, which is otherwise called as the plantar surface of the foot. So once they lose the senses, obviously they tend to develop some wounds from the medicine perspective. So yes, they call that as corn calluses. End of the day, it lead to a foot ulcer, which is nothing but a sort of wound that it tends to develop. So before it goes to the stage of creating an ulcer, it tends to thicken the skin at one portion of the foot, and the thick skin, which starts going further in depth, it will start closing the veins which are carrying the blood, or the blood vessels. So the blood vessels which are carrying the blood is closed because of the thick skin which forms in the plantar surface. And once the blood vessels got closed, that means that the blood which is here, it stays stagnant, and the blood which is coming from the heart, it comes until this, and as this passage is blocked, it goes back, whereas the blood which is here, it gets stagnated. So the blood which gets stagnated later on at a particular point of time, it starts creating a pus, and the other end of pus is what gangrene is, wherein it becomes to a situation where it can't be treated. And as the gangrene forms, there is no option to do that, because the blood vessels or the nerves would also get damaged, and the entire skin would have got damaged. And at the end of the day, the only option is to undergo amputation. So that is why they do the amputation and they go for prosthetics application. So this is the idea behind that. Like here you could see that if it is a normal foot, his blood vessels would be perfectly fine. But as the blood sugar level increases, the um, skin becomes loosened up, or even the blood vessels becomes loosened up because of the high amount of glucose which is carried in the blood, and the skin, the nervous system, everything loses its texture, and thereby it starts getting bulged because of the pressure which is created from the bottom, and it damages the entire surface area. So this is what it happens in terms of diabetic foot. So we can see that when the person is normal, he's fine, and once he becomes diabetic, the skin becomes loosened, and this is the time wherein if we speak to any diabetic patients, they would say that they started losing the senses in their foot, they are getting a tingling feeling. All these occurs during the second stage, and third stage is the one wherein the corns will start forming. Corns is nothing but the thick skin will start forming on, and then it leads to diabetic foot ulcer. So if we look at thick skins, so that is the area of interest where we'll be speaking about. In the next slide, we'll touch on that. But here you could see because of losing senses, these are some of the diabetic foot ulcers which happen at the plantar surface of the foot, and left untreated, it goes for amputation, which is a hard fact. Right. So we saw the medical perspective of it. We got a bit of an understanding where it is starting. Now we'll look at from the mechanical perspective. One thing is, we know that Let us consider a profile like this and let us put some load on top of it. So we know that when we start moving this, it'll, because of frictional force, it'll start getting eroded. Or now the pressure acting at this point is very high. On the other hand, what I'm doing is I'm chopping off some of the region, or in other terms, I'm increasing the surface area of contact for the same load. I'm keeping the load same, whereas I'm increasing the surface area of contact. So now I have increased the surface area of contact. Now definitely my wear rate will be less as compared to this. So this gives us a clear idea that once we improve the surface area of contact, it reduces the wear rate, or the load distribution would become better as compared to the pointed one. So this gives a clear idea that surface area of contact is an essential parameter. Let us consider a person. If he is weighing 90 kilos, theoretically 45 kilos need to go to his left foot and 45 kilos need to go to his right foot. Okay. Theoretically speaking, that's how it should be. But in reality, we could see that our foot profile is not flat. Our foot has a deferred profile. So based on our foot profile only, our load gets distributed. So for simpler calculation, let me take it as, let us consider this foot as 10 centimeter square area. Theoretically, the 45 kilos of load need to get distributed to this 10 centimeter square area. But because of the profile of our foot in the plantar surface, not all the 10 centimeter square area is getting distributed. Maybe roughly 40% of it goes off and only 60% is being loaded. That is, only 6 centimeter square area is being loaded with this 45 kilos of load. Wherein the rest 4 centimeter square area, because of the profile of the foot, it doesn't get loaded. And from the diabetic perspective, we saw that the area where the highest load is, that is the point where the pressure ulcers start taking place. So this 6 centimeter square area is the one which is taking the entire 45 kilos of load. In other words, if our foot is taking the entire load, then we wouldn't be facing issues when we all of us face this issue. Like if we turn our shoes or sandals that we are using regularly, and if we look at it, we will find that it has been worn off at only certain places. Some areas it doesn't get worn off. If our foot is taking the load equally, then the wear rate would be constant throughout. But that doesn't happen. That gives a clear idea that our loading is not done at all the places in the plantar surface of the foot. Our loading is done at a different way, or in a different way. In mathematical terms, we can say that only 60% of our entire body weight gets distributed through the foot, whereas the rest 40% it doesn't get distributed through the foot. And that we can see from live case situation. Turning our shoes, we can see that our shoes tend to worn off at only certain paces. That gives a clear indication of this. The same thing, if we look at a diabetic patient, wherever there is a highest wear rate, that is the point where the diabetic person tends to put much of his pressure, and that is the first place where we can see that the foot ulcer develops. Because of highest pressure that is occurring over there, it thickens the skin, and because of the skin getting thickened, it tends to close the blood vessels, as we have seen, and blood stops flowing in, and as we have seen, then they go for amputation. So this pressure is one of the major problem wherein amputation starts. Looking at the way how we tend to wear the shoes, like we have only two measurements. That is, very rarely we go for measuring the width of our foot or width of our plantar surface, but mostly we tend to just measure the length of our foot. And based on this only, we tend to go for selection of our shoes. But in reality, that should not be the case. there are so many other parameters which need to be measured when we go for selecting a footwear. And based on this, we have some standard sizes. We tend to stick to that, as we all know. In reality, we all fall under these three categories: either flat foot, normal arch, or high arch foot. This is the very primary measurement that we need to understand when we are selecting the shoes or sandals for ourselves. Flat foot are the people who are either too heavy or too bulky, which they might have occurred at over time, or you could see some children who are born as flat foot. Um, like that is the possibility for a flat foot, and children who are born with flat foot is roughly around 2% of the children who are born with flat foot. But data shows that because of obesity, people tend to achieve or come at a situation of flat foot. The second category, normal arch, people who are not obese and people who are not very thin, they fall under the category of normal arch, wherein if you look at the plantar surface of the foot, they will have a medium type of arch like this. And the third category, it is called as high arch foot, otherwise it is called as athlete's foot, wherein people who are more into sports or who are very thin, they are the people who tend to have this high arch foot, wherein they tend to have this arch region to be the highest one. And end of our research, one thing that we realized was, like when we tend to go for selection of our footwear, we need to understand what is the type of our foot, and based on that only we need to pick and choose the ready-made or readily available shoes. Like people who are with flat foot, they should only wear the insoles which are very flat. They shouldn't wear anything which has a heel underneath. And people with normal arch, they are the ones who can wear a shoe with a medium heel, not a very bulky one, a medium heel. And high arch one, people with high arch, yes, they are permitted to wear the shoes with high heels, but usually it tends to happen reverse. People who are fat and if they are short, they wanted to show themselves a bit taller, so they completely mismatch the type of shoe for their foot. And when they are healthy, they don't understand or they don't come across any issues. But once if they cross 40 or 45, as the bone density starts coming down, that is the time that we tend to face the issues of bone pain or ankle pain. This occurs particularly for the reason of poor mismatch of our footwear against our foot. So one piece of thing that advice that I would give you is understand the type of your foot and match the shoe according to the type of your foot to start with, rather than looking at the aesthetics of the shoe. To start with, just look into this and then you match yourself. So coming back to this topic, so this gave us a couple of ideas that once if we are improving the surface area of contact, we can do something in terms of reducing the pressure. And second thing is, because of friction that is happening, there is an irregular wear rate that we can see from bottom surface of the foot. So this gives two important things that we need to consider, these two parameters when we are designing or going for a shoe for a diabetic patient, because these two has a direct link with in terms of creating a pressure ulcer. The next thing is the type of activity. Like every one of us undergo two types of activity, or we tend to load our foot with two types of activities. One is static load. We just stand. That is the time that we exert a static load. But then when we are dynamic, move, run, walk, that creates a dynamic load. So we come across static and dynamic loading at every situation, and we exert this static and dynamic loads on our foot. So now it came to three situations. That is, in terms of footwear, we need to consider what is the static and dynamic load that we are giving, what is the surface area of contact, and how can we reduce the irregular wear rate. So these are the three things that we need to consider when it comes to designing a footwear. Yes, some people might be thinking like already there are some market available diabetic foot insoles. Yes, there are some market available diabetic insoles, but what they do is they just measure the foot size. What is your foot size? Is it size 8, 9, or 10? That's all that they measure, and all that happens is we are allowed to stand on a very soft foam. Uh, the market name is called as Eva foam, but it is more or less like you walking on a bed. Like walking on a bed is not a right solution. Maybe it might be a solution for first 10 days, but after that, that is not the right solution. And again, once if we start walking on these cushioned surfaces, it is not a good thing in terms of gait perspective that we'll touch in forthcoming slides. But one thing is the market available ones are not custom made. Those are just made according to the size, and those are the soles which are more or less like a soft material wherein you're asked to walk on, which doesn't solve the purpose because that doesn't understand what is the type of your foot and what is the loading that you're putting on, and that doesn't understand your pressure points or the point where the highest friction is happening. It doesn't understand it. It is just one more ordinary shoe that you get from off shelf. Right, moving to the type of people. If we look at the people, like here I have shown a bunch of people here. Like let us consider these two people over here. Let us say their foot size is size 7. It is very clear their static and dynamic loading is different, and the type of activity that they perform is also different. But our footwear need to be when we are going for a specific footwear, that need to be considered, but at the moment that is not at all considered. Okay, and yet another fact is if we just take one person, his foot style, his foot size keeps on changing until he arrives at a age of about 24, 20 to 24. It stops for most of the people. So the foot size doesn't go larger or changes after 20 or 24. Then it remains constant. But the type of activity that this person undergoes once after achieving a constant foot size keeps changing. So this parameter is not considered in a footwear design at the moment. So this gives us a very clear idea that we need to consider static and dynamic loading. We need to consider what is the surface area of contact, how we can reduce the friction, so that once if we are able to reduce the friction or irregular wear rate, we can understand where the ulcer is, we can cut it off, and very importantly, we need to go for customization, because even if we consider one single person, his activity changes. For that matter, like for us, we have been advised to change our footwear once every year because our weight doesn't stand normal. Um, we tend to keep on fluctuating in terms of weight. Even a kilo or up and down, that matters a lot when it comes to static and dynamic loading. So that is why we are always advised to keep changing our footwear once in a year. That is because of the weight changes. So customization is one of the important parameters that need to be considered. So these are some of the takeaways that we understood from this. And some people already might have a question like my grandfather was working or walking in the fields, and during that time he never faced any issue of foot ulcers. And why is that we are bringing all these new jargons now? Yes, they didn't. They were into agriculture. They weren't aware of custom footwear. But one thing that they did is they walked barefoot on the surfaces like this. Like either they walked on grass or they walked on clay or mud or sand. So what happened during this situation is when they walked on this, like the ground underneath, it tends to take the profile of the foot. That is the ground underneath, it tends to take the profile of the foot. So it is no more a 60% loading. the 100% loading was done by a, a person while he is on static or dynamic loading, because um, the ground tends to deform. But nowadays, what we are doing is we are walking on hard surfaces, and the ground underneath it doesn't transform according to our foot profile. So that is where the problem started. Okay. And again, there are many researchers across the globe which said that walking barefoot is good as compared to walking with the shoes, because the shoes doesn't give the right loading. And there were many discussions across the globe which says walking barefoot, but again, there are some discrepancies in that. Now I would like to share you one video wherein one of a professor from Harvard, he did a studies whether to walk barefoot or walking on a shoe is a better one. Here is a short video on that.
When people develop calluses, not only do they have thicker calluses, as you might expect, but those calluses manage to protect the foot without causing any loss of sensory perception. The shoe changes the mechanical properties of that impact, and it slows the rate at which the collision occurs by about threefold. And when that happens, the area under the curve, which is the impulse, the total amount of energy that's delivered up your body to your joints, increases by about threefold. And that means that when you're wearing a shoe, your body experiences really different forces than when you're barefoot.
We traveled to Western Kenya and did research in two areas with the same ethnic population, the Kalenjin. But we were interested in the effects of shoes, and so we went to a rural population where most people don't have shoes that they can wear every day, and we compared them to an urban population in the nearby city of Eldoret.
We brought an ultrasound up to the field, measured how thick people's calluses were. We brought up a force plate, which is a kind of a very fancy device to measure how much and how people walk. And we collaborate with a team in Germany that was able to measure the sensory perception of the foot at different frequencies and different amplitudes.
It was exciting for me, first of all, to demonstrate that, yes, indeed, people who don't wear shoes tend to develop thick calluses, which has not been previously shown. On the other hand, these calluses also provide protection. It makes the skin harder. And then in addition to that, these calluses do not appear to dampen the tactile sensitivity of our feet.
And of course, we didn't evolve to wear shoes, especially we didn't evolve to wear cushioned shoes. And so one of the interesting questions that this research raises is, we need to understand more what that consequence is for joint damage.
So it gave a clear idea that shoes are not the right solution, but walking barefoot is one of the right solution. But they didn't define what is the surface that we are speaking of. So moving to the next phase, we need to understand a bit about gait cycle. What a gait cycle is, in simple terms, by the age of 5, every one of us tend to acquire a type of walking style. That is, either we tend to lean towards the left or we tend to lean towards the right, and then we tend to develop a walking style. That style is called as a gait cycle. And when we are designing the shoes, we need to make sure we don't change the gait cycle, because once we change the gait cycle, it'll start creating issues in terms of our ankle and in terms of our bone joints. And yet another thing is, when we are walking, only 40% of the time our foot is on the air, whereas on the 60% of the time our foot touches the ground in one way or other. And we have seen from the earlier case that of the entire body weight, only 60% of the foot takes the load, whereas rest 40% doesn't take the load on one hand. And second thing is, when we are experiencing a dynamic load, in terms of dynamic load, of the 60%, again, only 60% of the time we touch the ground. So literally, we are losing another 20% of mark over here, wherein it is one of the serious issues which need to be considered when we are designing a custom insole. So narrowing down a couple of areas that we need to understand there are three types of foot, and we need to clearly mark where the pressure points of our foot are during static and dynamic loading. So this is what we narrow down further, and we'll see how we understanding this we tend to go for making of custom insoles. So in terms of this, what we do is we tend to pick the sample population. We ask them to walk on a pressure pad or a pressure plate, wherein the moment they walk on this pressure plate, we tend to understand what is his or her dynamic loading, what is his or her static loading, and based on that, we tend to completely custom design the insoles. So in order to custom design, what we do is we collect the patient data like their weight, um, and then we make them to walk on the pressure pad. And once if they start walking on the pressure pad, like we tend to capture where the highest pressures are. And along with this, we also understand what is the gait pattern. Like you could find a small line which is going on. This is nothing but it is called as a gait line. When we are designing a custom insole, we need to make sure the gate line doesn't change or doesn't deviate from this point to some other point, because the moment it deviates, it will start creating a pressure on other side of the foot, and that would damage the ankle or even the hip bones. So for that reason, we need to be very clear in terms of understanding the gait cycle and designing the footwear. So for this, we tend to follow a specific logic. We can't just make them to walk on one single go and capture the entire data. So we make them to do a couple of trials. And once they start walking on it, we tend to take at least 4 to 6 trials for a person. And of that, we tend to identify which is the best trial or which is the best match where we can fix it for him. And taking that, then we go for making a customized split insole. The idea here is simple. That is, wherever there are high pressure zones, that the highest pressures need to be offloaded, and wherever there is a low pressure zone in the foot, the low pressure zones need to be loaded. So that is what we tend to do it over here in terms of a customized split insole. And once we understand where we need to offload and where we need to onload, then we go for a 3D printing process, wherein in terms of 3D printing process, as I mentioned to you earlier, in this Polyjet printing, we have an option of changing the show hardness or changing the elasticity levels. If I need to give or if I need to offload in one particular region, all I need to give is a highest flexibility at one region. So that is, if I go for a show hardness of 20, it gives highest flexibility. And wherever I need to load a particular zone in the foot, I need to increase the show hardness. That is, I need to load that particular region. So in order to load that particular region, I tend to go for a higher show hardness, maybe 80 or 90, depending on the pressure distribution. And then I tend to go for loading that particular region. So here I have shown two case examples. One is a high arch foot and the other case is a normal foot. These two patients walked on that pressure pad, and here you could see that the pink zones are the ones with the very high peak pressures. You could read that 580 kilopascals of load has been distributed at this particular point. And when this person becomes diabetic, the first region where it goes for amputation would be this particular toe. Front toe would be the region where it goes for amputation. The reason is this is the place where the highest pressure is. And as we have seen through the earlier cases, like once if there is a highest pressure in a particular zone, it gets hardened and it starts closing the blood vessels and the blood stops flowing and gangrene occurs and the process stays there. So this would be the region where the amputation starts. And in the same foot, you could see the regions like 10 kilopascals, one region wherein 580 kilopascals and another region stays at 10 kilopascals. So there is a very drastic deviation in terms of pressure distribution. So what we are trying to do through this custom insole is we are Wherever there is a high pressure, we are offloading the pressures, and wherever there is no pressure, we are unloading it. And again, we did happen to see a case of surface area of contact. There are some areas where there is no surface area of contact at all. So we need to, along with loading the regions where there are low pressures, and still there are very low pressure zones or wherein because of no surface area of contact at all. So these are the regions where we tend to load it or we improve the surface area of contact for a better distribution, because at the very beginning itself we saw that once if the area of contact is increased, the pressure distribution would be better. So that is what we are trying to do it over here. So in terms of this, we can't manufacture a complete foot insole, a complete plane surface, because the pressure keeps changing from zone to zone. So what we do is we tend to split the insole into 5 different regions. So based on the 5 different regions, the pressure zones have been marked, and each zone gets a varied level of show hardness, and a custom insole is made according to this. And this is one of the custom made insole, which you can see, and it's printed in a Connex printer. And this, all they need to do is they can just insert inside the shoe and they can go ahead with in terms of walking. Moving to the data, here is a person, a normal foot person's data distribution. Like in terms of barefoot, you could see, as I have mentioned, that we tend to split the foot into 5 different zones, and you could see that only 4 zones have been loaded, whereas the 5th zone was not loaded when he is on barefoot. But the moment we went for a custom insole, you could see that the high pressure zones are being reduced, and some zones which need to be loaded, it had been loaded, and some zones where there was no contact at all, it is being brought in contact. So there is a, in general, there had been a sort of pressure reduction, and a contact surface area have been improved by wearing a custom insole. So there's the same data, but in a different format. You could see that the earlier case, there was a very drastic pressure distribution that was happening. Whereas once the person went for a custom insole, you can see the pressure distribution is within a certain range. It wasn't happening at a very drastic rate. And in terms of surface area of contact, it have been increased by roughly 14.3%, because earlier the surface area of contact was only 135 square centimeter, and now it have been improved to 157.5 centimeter square. Like in terms of pressure distribution, there was one zone where earlier the pressure was 0, and now it has been loaded to 135. This is nothing but, as we discussed with the 3 different types of foot, the arch region was not in contact in the earlier case, but now the arch region have been made in contact with the customized insole, and that have taken a load of 135 kilopascals from load. So this is a pressure distribution map before and after. You could see that in before, like there was a high pressure zone which was happening at this heel region, and now the high pressure zone has been relieved, and the non-contact surface area have been improved. Most of the peak pressures have been reduced in terms of a custom insole, and obviously we could see from this picture that there are some more number of contact points have been improved. So this is the one with a barefoot and one with a custom insole. This is for a normal person who is moving with that. And in total, if we look at it, zone 2, which was in barefoot, the pressure got reduced by 6.3% by using a custom split insole, and going for different zones, or on average roughly about 22%, there is a pressure reduction in terms of the plantar surface of the foot, and the surface area of contact have improved by 14.3% for this particular case example. The same way we did for a normal arch person. Only difference is in terms of um, normal arch, you would find this region, only one portion of the arch region doesn't go in contact. But whereas in terms of a high arch person, you'd find um, even that portion won't be in contact. So it is a completely a non-contact region would be there. So this is the pressure distribution for him. And we are up the same procedure, understanding the gait pattern. And you could find that for a normal arch person where there was no arch earlier, we have inserted a complete new arch like profile in between. And the pressure distribution has been mapped for this particular person. And here's the data distribution of before and after. And the contact surface area, being it's a high arch foot, you could find there is a major increase, roughly about 43% increase of surface contact area improvement in terms of a high arch foot. And we didn't stop over here. We just wanted to make from the Ayurvedic perspective as well, that whether the scientific research that we are adopting is a right approach or not in a right direction. So though we have a panel of doctors, a panel of orthopedicians, a bunch of diabetologists who are working with us, we also wanted to get an opinion from the other end of medicine as well. So one thing that is very clear is we all know that our nerve endings gets ended at the bottom of our foot, and much of the nerve endings of pancreas gets ended at the arch region of our foot. And at the moment, whatever the shoes or slippers that we are wearing, it doesn't go in contact with the pancreas and the nerve endings of the pancreas. So it doesn't get activated at all. So that is where the problem starts. And as we all know that pancreas is the one which has a major function in terms of insulin secretion. It doesn't get activated at all. It stays idle, and after a point of time it becomes numb as such, because it doesn't get activated at any point of time. So undergoing this particular research work, we did happen to get a confirmation from the other end of medicine as well, that yes, if we start creating a pressure point over here, or we start giving a sort of pressure over here, it tends to create the action on the endocrine glands. Even you can Google it for yourself, and that gives a good amount of idea behind this. So you could see that the arch region is the one where the pancreas, nerve endings of the pancreas come and fall. And now through this work, we gave a contact at this arch region. So that means that we are trying to bring the pancreas glands into action to some extent. End of the day, in this work, we are not claiming that by using a custom insole, your diabetes level will get reduced. The only claim that we are making is it will prolong the problem of ulceration on the foot. But again, as you need to stick to the diabetic protocol. But wearing a custom insole, number one is it provides a better comfort, and it would prolong the time of creating an ulcer in the plantar surface of the foot. And end of the day, all we need is we are giving more time in terms of going for a custom insole. And we did happen to apply for 2 international patents, and 2 Indian patents are also on the way in terms of this particular research. So the key takeaway over here is we did happen to go with static and dynamic loading situation. We understood what is the surface area of contact and what is the impact of surface area of contact in our foot, how we can reduce the friction or wear rate in our foot, and finally we did happen to address the issue of not only aesthetics is important, but understanding the pressure distribution, understanding how our loading changes and how our weight impacts in terms of the foot loading all of those parameters which need to be considered when we go for picking our shoes. So customization is very crucial. And one final conclusion that we came across with this research is not only a diabetic patient need to be aware of this custom insole, every one of us need to be aware of going for a custom insole, because all we do now is we just stick to the size of our shoe, but that is not sufficient at all. We need to understand where we are putting the highest pressure, and based on that we need to go for a customized insole, because if you are not diabetic, definitely it will start creating orthopedic issues. When we are hale and healthy, when our bone densities are good, we won't face the issue. But the moment the bone density starts coming down, we obviously we tend to face the issues in terms of orthopedic issues at a later point of time. So the best thing is going for a custom insole, and selecting the right footwear is very essential for a better walking posture as well. So the takeaway that I would say, just as customize your footwear, which is very essential. And I would like to acknowledge Dr. Shokma, who worked along with me on this particular project. And I'll leave you with a thought. And now I'm pretty much open for any questions.
Participants can post your questions on the chat box.
Right. In terms of the cost of a custom insole, I would suspect it would cost roughly about 4,000 to 5,000 for a custom insole, if you're going for it, because even if you check the price of claimed the so-called or the so-claimed diabetic foot insole, that would cost you close to about 3,000 rupees. But rather that, if you are able to go for a custom insole costing 5, that would be a better deal to go for it. At the moment, we have somebody who is planning to start this within the southern part of India. So, like, you tend to put an email to me, or you just contact me over phone. I'll give you those details. I could see a question here, the footwear, whether to continue the medicine. Obviously, you need to stick to the medicine, as I mentioned. But the only thing is, the custom insoles would prolong the time of creation of foot ulcers. It won't cure your diabetes, but it would prolong, or it would buy you time from the ulcer causing wounds. And second thing is, as it tends to create an action on the pancreas gland. Maybe it would try to improve the level of insulin level in the body.
Tangapandian sir, you can unmute and ask question. Your mic has been enabled.
I think ASIC is providing such shoes, sir, Insole shoes. Where we can get the test results in India, sir? So if I want to customize a sole means, whom I can...
Like at the moment, there are a couple of people who are doing it, sir. I know one person who is doing in Bombay, but again, it is not completely customized. They just stick to the profile. But most of them, what they do in terms of customizing is they tend to look at the 3D profile, but looking at the 3D profile is not sufficient. That is where we went for the patent. like just measuring our foot size and looking at the profile is not sufficient. We also need to understand where our highest pressures are, where our lowest pressures are, and that offloading need to be done. If that is not done, then I wouldn't take that as a custom insole.
Okay, sir.
Yeah.
Sir, one of my coach usually tells that you have to walk by pressing the big finger, the right inner side of your leg.
The front toe, you mean?
Yeah, yeah.
Okay. Yes, like they tell that one reason is I suspect you would be an athlete because if you look at it, means while you're running, your highest pressure lies in terms of your front toe or the big toe, or that is the gliding one, which tends to give you the force while you run. Um, it is more or less like that is the gliding one, but in reality we need to understand it is fine when you're involving a sport or when you're involving a dynamic activity, your highest pressure, now your concentration would be on how am I going to get that force of or how am I going to get my momentum. So that is where your concentration would be. But when you're looking at in terms of health perspective, like the important thing that we need to consider is like how better am I distributing my entire body load to the surface of the foot. Okay, sir. So that is where uh, we need to come back to this customization aspect.
Okay.
Thank you, sir. Any other questions, sir? Like it won't prevent diabetes. It would, number one is because of a better contact in the pancreas gland, it would improve the insulin levels, number one, which is very crucial for the diabetic patient. And number two is it would reduce the foot ulcer, chances of foot ulcer. Those are the two things that this would do. It would definitely reduce the possibility of foot ulcers. So, any other questions? Okay.
Mr.
If you
Satish Kumar, you have been given a mic for asking question. Mr. Satish Kumar. Mr. Satish Kumar, you can unmute your mic and ask question.
Sir, this is Dr. Ramathirumurugan from MCET.
yes,
In
sir.
Ganga Hospital, they have this measurement technique as well as they are giving footwear, but that is handmade, I think. What is the difference between the insole and footwear? They have given complete footwear for this particular problems.
Okay, sir. Yes, sir. In Ganga, they use this completely for orthopedic application, wherein a person after undergoing a surgery or bone surgery, they wanted to make sure their gait pattern is being retained. So for that application, they use it. And number two is, yes, in Ganga also they tend to they tend to give you an insole. But as I said, that is again one of the market available insoles, wherein it is more of like a cushioning sort of thing, which gives you a comfortable feel. But if you look at it, whether you're getting a right pressure distribution at your foot, no, that is a missing thing. And one of the doctor from Ganga, he's also associated with us in this particular project, and we are aware of that particular thing as well. Yes. If you go there, they'll ask you to stand on a glass-like plate, and that they tend to take a scan of your foot. That is, they are taking a 3D scan of it. So in terms of taking a 3D scan, they tend to see the profile of your foot, but the pressure distribution is not considered. So that is the thing. That is the difference between that particular situation and this one, sir. And again, if you look at the insole, it will be a complete flat insole, which is made of single material. But here we are splitting one insole, we are splitting into number of zones. And because our foot, for each and every zone, our foot pressure is changing. So we try to understand where the highest pressures are, where the lowest pressures are, where the medium pressures are. And wherever there is no pressure, we tend to, as I mentioned, we tend to offload and onload it. And while making that, we tend to make sure we stick to the gate pattern as well. So that is the difference between this work and the market available work. And that is where our patent moved up the ladder. To our knowledge, even Nike doesn't do this. So that is where we applied for a US patent on this.
Yeah, but they are also measuring this pressure and gate pattern in pressure pads.
Yes, sir. They measure it for orthopedic patients.
Yeah,
not for the diabetic patients.
Yeah. Okay. Thank you.
Okay. Thank you, sir. Thank you.
Thank you very much, sir, for the wonderful and informative session. The session was blended with both medical and as well as mechanical aspects of need to develop customized insole for diabetic patients. Thank you very much, sir. On the behalf of the management and the mechanical department, I render my fullest thanks to you, sir, for the wonderful session.
Thank you, sir. Thank you, sir. And I'd like to thank the participants for their patient listening. And any questions, you please post an email to me. And